Hello everyone and welcome to our sessions on AI. So we did our last project that is based on contouring as well as our intensity detection, and we were able to find out two data sets, that is nothing but one is samples and one is responses. Now what we'll be doing is we'll be doing a project on facial detection. So facial detection has been a common thing in most of the cameras, most of the it is used to detect your faces through your cameras or through videos or through photos or anything. So it is an algorithm or it is a technique to detect the faces. So in machine learning, so we have a technique of facial detection using a Haas cascade classifier. So I'll tell you what that algorithm does, but what is facial detection all about is nothing but detecting faces. So whenever you have images of people, so if you are able to detect the faces of those people, so then it is called as facial detection. So this you can consider an example where we are able to detect people's faces. So this is the project that we'll be going to do. So what we'll be doing is we'll be taking in two use cases. The first use case is nothing but we'll be taking the use case where we will give the photos or we'll give an image, so the face will be detected from that image. So second use case is where we'll be giving our live video from our webcam, so that can detect all our faces that is coming out of the webcam. So it is nothing but our live streaming that we'll be doing. So from the live streaming, we'll be detecting what are all the faces that our webcam is able to capture, and we'll be drawing rectangle. So why we need to draw rectangle is once we detect the faces, we need to show the output to the user, right? So how will the user or how would anyone understand whether your face is recognized or not? So by drawing a rectangle on the faces, we can recognize the faces. So that is what is our whole project all about. So first we will take in an image. So I'll just explain you how the steps goes. So step is nothing but image acquisition is the first step. So image acquisition. So this image acquisition is nothing but taking input of images, either image or live video. So you can take in by both ways. So either image or live video. So image can be taken, that is from your webcam or from any image in your directory. Live video also, live video from your webcam or any video that is in your directory. So after doing that, what we need to do next is we need to apply to the facial recognition algorithm. So we need to apply the image. So we need to apply the image to the facial recognition algorithm. So after that, what we need to do is pretty simple. We need to draw the rectangle. So draw rectangle on the faces. And display. So we need to draw a rectangle on the faces and display. So this is the entire thing. So we acquire the images, we put it to the facial recognition algorithm, and we need to draw the rectangle on the faces and display them. But before doing that, how to train this algorithm is very important. So how this algorithm is training? So this algorithm is training using a training data set called as Haas cascade classifier. So this is nothing but the algorithm which we are using. So classification algorithm, you know that it will predict whether it is a yes or no, true or false, good or bad. Here it will predict whether it is a face or not a face. So Haas cascade classifier data files or XML files. So XML files is similar to your nothing but CSV files, but these XML files will have facial feature information. So how will a face look like? All those information will be stored in these XML files. So we'll go into the algorithm in detail and understand how actually our Haas cascade classifier is trying to predict our images. So this is very important to understand. So to understand Haas cascade classifier, so Haas cascade classifier is nothing but an image processing based classification algorithm. So image processing based classification algorithm is it consists of a lot of mathematical processes, lot of mathematical functions which are used to do some classification operations. So majorly whenever you hear about Haas, so Haas is nothing but for image. So whenever you hear about Haas classifiers or Haas algorithm, it is basically for image classification. So whenever you want to classify a cat or dog image or a human face image or a car image or a person, whole body of a person image. So any kind of image, if you want to classify it from the rest of the images, you will use this Haas classification algorithm. It is not only restricted for face, you can use it for any other thing. There are a lot of Haas classifier files that is available, or even you can take in the Haas classifier algorithm from the various sources in the internet, and you can give the images and you can train the algorithm, and you will get these XML files. So what we will be doing now is we will not be generating the training files. Instead, we will be using the ready-made XML files to detect the faces. But how is the algorithm actually trained is we have our facial images and non-facial images which are given to the algorithm. So Haas classifier algorithm works in two ways. So there is one thing called as horizontal feature. So this is horizontal feature. So horizontal is nothing but on a straight line, and vertical features is relating to your height. So two features it will try to detect. One is your horizontal features and the other one is your vertical feature. So what it is doing is, you can see here in horizontal features you have your eyes. So how is your eyes differing? So if you want to draw an image of eyes, so this is the image of your, like you can consider this as your eyes. Inside that you have a dark eyeball. So what you consider here is, actually what is happening here is, inside your eyes there is a dark eyeball. So you are seeing the difference between those pixels. So this is the lighter pixel white and this is the darker pixel black. So you are able to see the differences in the color, and you are able to see the differences. That is nothing but you can see how the pixels are varying. So you can see how the pixels are actually varying. So this is the black pixel, this is the white pixel. That is how it is detecting your horizontal feature. So Haas classifier will detect features in horizontal and vertical manner. So it is a mathematical algorithm which is like a morphological image processing algorithm. How it basically works, morphological image processing algorithms. Nothing but it will see through the whole image. So it will see through this whole image, and there is a small filter which goes through this entire image row wise and column wise. That is how your face image and non-face image are classified based upon the horizontal and vertical features. So it will go horizontally to see what are all the difference in the intensity. So entire Haas cascade classifier or any image classifier works on difference in the intensity values. So we give a grayscale image, it will see how the intensities are different. So it is finding out there is a difference in intensity between black and white pixels in the eyes. So that is one difference. And your eyebrows are also dark. So that is why that is also considered as one of the horizontal features. So what are the vertical features? Vertical features is nothing but your nose is one vertical feature. So all those things, shape of the face. So how all the lips is also a horizontal feature where you can detect the darker shade of color in the lips. So using all the difference in the intensities in the horizontal as well as vertical lines, it is able to differentiate between face and non-face. So only the information related to face is stored in this XML files. So XML files will play a huge role for detection. So once you have an XML file with you, it will be very easy for you to understand and train the model. You don't need to train it everywhere. So you can see each and every smartphone has a facial recognition, not only facial recognition, face detection. So if you open your selfie camera, so on your face, you will get a rectangle. So that is doing with the same Haas classifier algorithm. It is a very simple algorithm. You don't need to train it every time. Once the algorithm has been trained for millions of images of faces, so you don't need to train it each time. So it is enough if you do it once. So that is what is your entire algorithm is based on. So to understand, the project that we are doing is face classifier. So in the entire image, it will identify the face and draw a rectangle on the face. So how it is identifying whether it is a face or not, using this Haas cascade classifier. So how does Haas cascade classifier works? So this algorithm is based on complex mathematical functions. So what it does is it is going to it is getting trained, or we have trained models which have been trained with face and non-face images. So in face images, it will try to find out horizontal and vertical features. So what is horizontal features? That is your variation in intensities between your eyeball and eye. So eyeball is black, eye is your white in color, so it is variation in intensity. Then eyebrows are darker compared to your skin color, so that is different. So then you have nose, which is your vertical feature, and lips, which are darker, so that is also your horizontal feature. So like that, it sees through various intensities in the different in the image. So it is like checking through the different intensities and making note of everything. So that is how it is able to classify your face and non-face image. But we are not trying to train the data set now. So we have a ready-made file, that is our XML file. So we will be using that XML file to actually try to predict the faces or try to classify the faces in the images. So this is what the entire project that we are going to do now. Yeah, so this is the actual XML file that has been generated. So you can get this XML file on GitHub, on Google, or anywhere. Even I will post the link of the GitHub repository for various XML files, for cars, for faces, for human body. So lot of XML files can be found that can be used for detecting. So what we can try to do is we can open this XML file using your Notepad or any other text editor that you have. So I will use Notepad. So you can see here, this is an XML file for detecting the frontal face. So what this is having is all the pixels and all the intensities values that will be used for training the faces. So what are all the face intensities, how a face looks like, and the horizontal and vertical features, each and everything in the form of pixel intensities. Like millions of images have been stored. So millions of image data regarding the pixel intensities and how the intensities varies are stored in the form of XML files. So this is the default XML file that we have. So how to use this particular thing in our program and how to detect faces is pretty simple. Okay, so what I will do is I will just open a Python program. So I will use this idle. I will open a Python program and start. It is a very simple concept that can be done within a few lines of code. So first I will save it as face.py or face detection.py. Anything is fine. So it is in my desktop. So in my desktop I have my face detection project. So inside this I will save it as face.py. Okay, I will save it as face.py. So face.py is done. So I will import my CV2. So I will import CV2, that is standard. I will import my NumPy. So that is also standard. So I have imported my NumPy. So what I will do is I will import I will read my nothing but my that is nothing but frontal face or the face XML file. So how to read this face XML file is I will call this variable called as face. So what I will do is I will use this cv.cascade classifier. So cascade classifier is nothing but the way or the command to read our particular classifier file. So cascade classifier is a command to read our classifier files. So which is our classifier files? That is nothing but Hars cascade frontal face.xml. So this is our classifier file. So I can just copy the entire thing. So .xml is the file format. So I can copy this and I can go back to my Python program here and I can type in this. Similar to your pd.read CSV. So how you read your CSV file, this is the way to read your XML file. So you can read your XML files using Hars cascade frontal face.default XML. So that is why you are reading it. So after reading it, all the information regarding the frontal face is stored in this variable called as face. So if I want to print this, I can print face. Okay. So I can print this face. So that will give you all the information about the, CV2 dot. So this is CV2 dot, cascade classifier. So if you want to print the face, it will give you all the information that was stored in your cascade classifier. So it is storing all the details. So it has all the details regarding whatever is the information in Hars cascade frontal face default XML file that will be stored in this variable called as face. So that is inside this. So then what should we do is we should read an image file. So what I will do is I will just go to Google and find some group photos so I can detect some faces. So I went to Google and searched for a group photo. So I found pretty much this photo. So this is okay. This can be used for detecting our faces inside the picture. So fair enough. So I've named this photo as group photo. So similarly, I will use my variable called as img, that is image is equal to cv2.imread. So I will read this image. So the first method is reading from an image. So second step is reading from my webcam to see how my face is actually getting detected. Okay, so that is nothing but my image is nothing but group photo.png. So I will name it as group photo.png. So group photo.png is my whole image name. So let me cross check once again. So where is it? Okay, it is in my facial recognition project. So group photo.png is my image. So to cross check, I will use my cv2.imshow command to show you the picture. So this will be the window. So after depicting that, I should give the image name, that is a variable. So if I show that, I should be able to display the facial images. So this is fine. Okay, I am able to do it. So it is taken in properly. So make sure they're in the same location or given the fully functional directory. Next thing is conversion to grayscale. So understand this, the intensity of the pixel can be checked only on the grayscale image. Even color image it can be done, but the algorithm will become much more complex, and Haar's cascade classifier algorithm works only for your grayscale image. So for grayscale image you can detect, but the same rectangle can be drawn on your color image also. So understand this concept. So we will detect using the grayscale image. Once we detect the location of our face, the same location can be placed on our color image and the rectangle can be drawn. So this will help you easily do your algorithm with a lesser computing power and get the same result. So we'll do this algorithm, apply this algorithm on a grayscale image, and since we know the XY coordinates in face detection, the major task is getting to know where our face is in the image. After getting to know that particular thing, so you can easily try out, or you can easily plot those face in the color image also. So to convert into grayscale image, cv2.cvt color. So the image name is img. So how to convert it? It is cv2.color underscore bgr to gray. So to gray. So this will convert my image. So I can show this image again. So if you, so I can just cut this and I can paste it here so that you can see the grayscale image of that particular thing also. So instead of image, I should use gray here. So that will depict my grayscale image. So you can see the grayscale image of the faces. So done. So grayscale image is done. So half of the work is done. Now we need to apply it to our algorithm. So how will I apply to my algorithm is, so our algorithm will detect the faces and give out our X, Y and WH coordinates. So very important, another few things that I need to show here. So how after detecting our faces, so what it will do is consider my face is this. So I am having my face, that is here. Then I am having my mouth, so it is able to detect my face. So how will it detect my faces? Once I give my entire image to the algorithm, it will find out or draw a box. It will not draw a box. It will find out the boundaries of my face. So what is the boundaries? X comma Y and W comma H. What is W? Width and height. So this is the parameter it is going to find out. So once I have my face detected by the algorithm, it will find out. If I have multiple faces, what is it going to do? So if I have multiple faces in an image, so it is going to find out the same thing. XY and WH and XY and WH. So all these things will be stored in one variable. So we need to store all the XY coordinates, W and H coordinates of various faces of my image in one variable. So that variable is called as faces. So what I will do is I will initialize a variable called as faces. So what it will do is it will apply the algorithm and give us the XY and WH of each and every face. So XY is the starting coordinate, leftmost point of the nothing but my face. So then what I need to do is I need to find out the width and height of my face. So each and everything will be stored in our faces. So what I will do is I will apply my cascade algorithm. So what is my cascade? So face is my cascade classifier file. So face dot detect multiscale. So what is detect multiscale is nothing but detect the faces. So what is multiscale? So even if my face is small or even if my face is large, so it needs to detect each and every face irrespective of the size. Even if it is small or big, it needs to detect. On which should it detect? It should detect on the grayscale image. Then I need to give my scaling factor. So I will give my scaling factor as 1.3. So what is scaling factor is, see, this detection is happening on a morphological image processing way. What is morphological image processing way? So once you have this entire image, so there are different, once I take in this entire image, so then I will have faces here. So one face will be bigger, it will be more zoomed. The other one will be of lesser zoom. So whatever size of the face that it is trying to detect. So how it is detecting? It is applying a small filter that will go through this entire image, both that is row wise and column wise. So it is going to go through this entire image, but while going through, if it is a bigger face, it might miss the particular face, right? So what it will do is, whenever it is going through all these things, so this entire image will be scaled. So the entire image will be scaled to the particular level. So even the big faces will become small and it will fit into this filter. So each and every part of the image is getting scaled. So that is nothing but my scaling factor 1.3. So 1.3 to 1.5 is suitable for face detection. So that is given by the Haas classifier, the person who developed the Haas classifier. So the scientists have given that 1.3 to 1.5 is the best scaling factor to find out the faces. So what scaling is doing? It is converting your bigger faces to the same scale also, smaller faces to the same scale also, so that this filter can move about and detect the faces. So scaling factor is 1.3. So then we have something called as neighbors. So what is neighbors? Is nothing but neighbors is nothing but telling you how many features. So what is how many features is very important to understand. So in a face, there are eye features. So that is nothing but horizontal eye features. Then you have nose. Then you have eyebrows. Then you have mouth. So then you have forehead. So forehead will be also one of the features. So lot of features will be there. So how many features? So there and many more. That is not related to only this. There are a lot of other features also that is involved in detection of the face. So neighbors is telling you how many features should you consider to detect it as face. So sometimes sometimes what happens is I need to tell how many features. So whether minimum 6 features should be detected to consider to be as a face, or minimum 4 features, or minimum 1 feature. So if I use 1, even if it is not a face, or even if there is any black and white color intensity difference, it will detect as face. So if I use more features, then if the image is not clear, or if the if the image is of not good clarity, then it won't detect even a face is detected also. That is why you need to choose optimum number of features that needs to be selected. So if 6 features are detected in that particular region, so can I detect that as face? So you should tell how many neighbors. So the average or the default value that we take is 5 to 6. So we'll take it as 5. So this is how your multi-scale is working. So first you take an image, grayscaled image. So then you give it a scaling factor where it will scale each and every region. So it is getting zoomed in or zoomed out, so that our scaling filter can go through the entire image. After scaling it, we need to tell how many neighbors. So how many neighbors should be detected in order to consider it as face. Neighbor is nothing but features. So if 5 features are detected relating to face, so can I tell it as my face, or should I detect more features? So you are giving the threshold value for detection of the faces. Now we detected the face. All those information is stored in this variable called faces. But one more thing we need to do is, after detection of the faces, we need to draw the rectangle. But how will you draw the rectangle? You need to know the x, y and wh of each and every nothing but the variable in faces. So what we will do is, for x, y, w, h in faces. So what is this doing? It is telling us what are all the x, y and wh variables that are there in our faces. So faces has that x, y, wh in of all the faces it has detected. So we need to draw the rectangle there. So what we will do is cv2.rectangle. So drawing function. So we'll draw a rectangle in what variables? We need to draw the rectangle for the which image. So we'll draw it for the color image. We will not detect even though we have detected in a grayscale image, we'll draw it for a color image so that I can draw those particular thing in the color image. So this is what we'll do it. So this is very important. That is why we are choosing this IMG. So then what we are trying to do is we are trying to do some more things. So what is the next thing that we are going to do? We are plotting the rectangle. So if you want to draw the rectangle, what is the important thing? The leftmost point. So XY is my leftmost point and the bottom right point. So how will I get my bottom right point? X plus W and Y plus H. So that will give my bottommost point. So XY is my top left point. Bottom right is X plus W and Y plus H. So I need to tell which color should my rectangle be. So we'll choose blue color. So that is better. Blue. So red will be 0, green will be 0 and red will also be 0. So I got my blue colored. Then thickness. So I can use it as thickness as 3. So thickness of my particular rectangle. So after doing this, what I will do is I will just use CV2 dot IM show. So this will show my image. So face, so this I will remove. So I don't want to show the particular old image. So face is my window name. So IMG is my image variable which will show my image. So what we'll do is we'll try to show this image. So we'll wait for the output to appear and we'll try to see what is the image that is available. So this is the particular output it has got. So it has found out 3 faces. So even though other faces were there, it could not find out those 3 faces. So what we are trying to do is, so we are trying to recognize the various things in our whole image. So this is what it has done. So it has successfully found out 1, 2 and 3 faces, but this face and the other 3 faces it couldn't find out. So why? Because it may be due to the image and we are given more number of features also. So it depends on the image. This is a frontal face XML files that will detect only if frontal faces are there. Even if it is a slight disturbance, it won't detect. How you can change the detection is you can either play with this scaling factor as well as this particular neighbor. So what I did was I increased my scaling factor I decreased it to 1.05. Then I've kept my nearest neighbors as 5 only. So we'll see how it has detected. So you can see here if I decrease my scaling factor, so it is detecting more and more faces. So it detected all the faces, but it did some false detection also. So that is also there. So on the same way, I will try to increase my features to 6 or 7. So I will increase it to 6. So let me see what is happening. So if I try to increase it to 6, so the same result it is not detecting her face, but it is trying to detect the other faces, but false rectangles are also being drawn. So I'm not telling this is a 100% correct algorithm, but this is a fairly good algorithm when you consider straight faces. So it will try to detect those straight faces also. This is one method that you can try to do it. So this is one of the methods you could try to do. So how do I do it for the next case scenario for a live video? So if you want to do it for a live video, it is pretty simple. So you can consider the horse classifier as itself, but instead of reading the image, so cv2.im read is not necessary. So what we will try to do is, first thing is what we'll try to do is we will try to read our image through the video. So how do we read our image through video? cv2.video capture will read our image through our video capturing mode. So what is video capture? It will see through the live webcam of our particular system. So I can use this cv2.video capture function to get access to my live webcam. But here I need to mention 0. Why? Because if your system has a webcam, the default webcam is 0. If your system doesn't have a webcam, if you insert an external webcam, it will be 1. So default webcam is 0, external webcam is 1. So be clear with that. But this should happen in a continuous fashion. So what I will do is I will put it in an infinitely long loop. So while true is an infinite loop. So I will put all these things in an infinite loop and make sure that they are in the infinite loop, because this will actually what will happen is it will actually be showing each and everything continuously. So each and every time I will capture my image through, so image is not captured here, so video will be captured. So what we can do is video will be captured here. So after getting the video, you need to get the frame. So very important concept to understand. So whenever I am trying to do this CV2.video capture, so it will be capturing my frames continuously. But what I need to do is I need to get the individual frames. So as you all know, video is a collection of individual photos. So video will be continuously giving me the video footage. So but my video cannot be applied to my algorithm. So what I need to do is I need to apply the image. So how will I apply the image? It is simple. So return comma frame. So what is return? Whether if my video camera or if my webcam is working properly, it will return a true. Else it will return a false. So frame is nothing but the individual picture that is taken from my video. So there is a function called as video capture underscore read, or that is nothing but dot read function. So video underscore read will read my particular data or my video footage. So it will return frame. So it will return the frame. So that frame can be converted to grayscale here. So this frame can be converted to grayscale. So after converting the frame to grayscale, so it will detect the faces and it will draw the particular faces. So this is like an infinite loop that will be taking place. But what I can do is I can take this particular thing. So what I can do is I can even put a closing way. So what is closing way? This is an infinite loop. So if I want to come out of this loop, so I can use this cv2.wait key. So which will wait for me to enter a key. So I will enter cv2 of wait key is double equal to, okay, cv2.wait key of 1 we will choose because our default keyboard is 1. So cv2.wait key of 1 is double equal to ORD of Q. So what is ORD? It is nothing but if I type in the value of Q, that is nothing but quit. So then it will stop execution. So that is what it is doing. So I will put a break statement here. So it will come out of that loop. So until then the loop will be executing. But what I should do this, I should put this cv2.timeshow function also here. So why I am doing this is, since this is an infinite loop, it will be running continuously. But what I want to do is I want to quit it, or I want to come out of that loop whenever I press a Q button or something. So whenever I press Q, it should come out of the loop. So for that I am using this cv2.wait key of 1. My default keyboard is equal to ORD of Q. So what is ORD? That is nothing but whatever input of our keyboard that has been taken, it is in Unicode or in ASCII. So ORD of Q is converting it into Unicode character. So if the key I press is equal to Unicode character of Q, then break. So it will break. So it is not IMG here. It is again frame, because I am not using my static image. I am using my video. So simple. I will capture the video using cv2.video capture of 0 from my webcam. Then after capturing it, what I will do is I will store the video in the video file called as variable called as video. Then I'll put it through an infinite loop. So what that infinite loop does is every time it will capture the frame from the video, give it to the grayscale image, detect the faces. After detecting, draw the rectangle, then show the face. After showing the face, it will be repeating in the same manner unless I press this Q button. So it will come out and it will quit. So after quitting, what should happen is I should destroy all the windows. So what I will do is I should stop the video from taking place. So video dot release. So this will stop my video recording. So video dot release will stop my video recording. Then I need to destroy my windows. So cv2 dot destroy all windows. So I need to destroy all the windows. So I will destroy my windows so that it closes my particular file. So this is how my entire process is working. So very simple. So instead of taking in cv2.imread will take an image. I don't want to take an image. I want to take my webcam footage. So cv2.video capture will fetch it. 0 is for my default webcam. 1 is for my external webcam. So again, video is taken, but I can't put my video into my facial detection algorithm. So what I will do is I'll convert it into frames. So video.read will convert it into frames and will give a return value. Why this return value is, in case my video is not detected, what happens is only the black screen will be given to this and you won't be able to see the output. So it won't detect any faces. So instead of giving the black screen, it will also give a return called as true. If it is successfully able to capture video out of my webcam, it will give return value as true. So then if the return value is true, so this will continue. If the return value is false, obviously it will come out of this loop and it will tell that there is an error stating that webcam is not working. So this is the thing about this entire process. We'll try to run and we'll see whether it is detecting our faces. So my webcam access is given. So if your webcam is not coming, just check whether your webcam access is given or not. So my CV2 window should load now. Okay, one small error that I'm facing. Where is the error that I'm facing? Okay, CV2.rectangle, it should not draw on the image, it should draw on the frame. So that is the small change. CV2.rectangle should draw on the frame, because in the frame only you should try to understand, right? So this is a continuous video capture and video streaming process. So it is able to detect my face now. So you can see my face right now. So it is able to detect. So whenever I press Q, it is stopping. So that is what this entire process is all about. So it is able to detect my face, and it is also able to give out the particular frame that is nothing but a rectangle on my face, and also it is able to print that face on particular CV2.window. So that is how this entire process is happening. So this entire process is done. So this is with the simple project on how to detect the faces in a particular video or image. But I also wanted to give you some access to some XML files which you can use and which you can try it out for your different projects. So guys, you can just go to www.github.com/openCV/tree/master/data/HarsCascade. So this is the file. So you can see here frontal face, cat face, eyeglasses, eyes, then you have left eyes, license plate. So then you have lower body, then you have smile, then you have upper body. All these XML files are already done. So I can take these XML files. So you can play with the scaling factor. So each and everything will have a different scaling factor. You can play with scaling factor and the neighbors. So then you can detect all these things. You can detect your eyes. You can detect your nothing but your lower body, upper body, the full person's body. So all those things can be detected in this particular example. So go to this particular directory, github.com/openCV/tree/master/data/HarsCascades. So I will put this link also on the tutorial so that you can go there and you can try to fetch these HarsCascade files and you can try out for the different projects on your own. So this is the like an assignment or a project work that you can do to detect different files. So this, you can play with the scaling factors and neighbors. So you should play with it. Then only you will get optimum output. So this is with the entire project on facial detection. So thank you guys, and I hope you have enjoyed it and understood the whole concept on facial detection, and thank you.